So show that the relation R in the set of integers, right, given by R is equal to A comma B such that 2 divides A minus B. What is the meaning of this? Can you visualize and tell me what are they trying to say? Can understand the meaning of this equation? What are they saying? If you take an ordered pair from the relation, right? In that ordered pair, what are the elements? Where does this A comma B come from? They come from the integer set. So A and B are integers. If you take there are two things, okay, I want you to concentrate. There is something called as difference and there is something called as subtraction. I think I've told this already. So what is the difference between them? So when I say difference between 1 and 2, how much is the answer? It is 1. Whereas 1 minus 2 is minus 2. So when you take the subtraction into consideration, you take the sign into consideration. Whereas when you talk about difference, the difference between 1 and 2 and 2 and 1 is 1. Right? Because that is a relative thing, this is actual operation. Having said this, here, are they talking about difference or subtraction? The subtraction. So that is why I'll tell you why I'm stressing on that point. Okay. See, A comma B is there. I have an integer. Let me take a number and understand. Suppose I take the number as 1 comma 2. Right. So if I take the difference between these two, first of all, can I consider this kind of an element in the relation? Can I take this number 1? Can I take this ordered pair 1 comma 2? Observe. Don't just accept whatever is. I should take the ordered pairs from the relation only in such a way that the subtraction of these two should be divisible by 2. Meaning, those two numbers should either be odd numbers or they should be even numbers. Makes sense? Right. Suppose I take 1 comma 3. Both are integers in the first place. And what the subtraction 1 minus 3 is going to be? Minus 2. And it is divisible by 2. I am getting a reminder as 0. It is divisible. Right. Similarly, if I take the numbers 2 comma 6, then what will happen? Minus 4 divided by 2 is going to be minus 4. Right. So I'm not going to take the generic value. So I hope you got a hold of what we are trying to talk about, right? So concentrate. Now, first thing is they are asking us to do that it is an equivalence relation. Means what am I supposed to do? My job is to do all the three. Right. So we'll go one by one. Let's think of what is reflexive. Meaning, in this relation, can I take the ordered pairs of the form A comma A, B comma B, C comma C like this? Can I take it? Where this is an integer, this is also an integer. So what is the difference between them? 0, and 0 is obviously divisible by 2. Since in this relation, I will be able to find these kind of ordered pairs. Since A comma A, B comma B, C comma C, everything belongs to this relation R, I can call it as the reflex. Yes, it is reflex. First checklist is clear. Similarly, had it been symmetric. So what is it? First, I need to assume if A comma B belongs to R, if I write the statement, what am I trying to tell people? I've taken A and B as those numbers which is satisfying this relation. Will I be able to find the reverse of it? For example, if I take 1 comma 3, will I have an ordered pair 3 comma 1 also existing? Why? Because 1 minus 3 is minus 2 by 1, 2 is minus 1, which is divisible. Right. Similarly, 3 comma 1 is also going to give me plus 1, which is again the remainder 0. Right? It is still existing. Wait, I'll ask you one question at the end. Concentrate. Implies P comma A also belongs to R. Yes, it is right. What about transitive? See, for transitive, for example, if I told the difference can be the difference between the numbers you choose should always be an even number, right? So I can take, suppose I take the numbers 1, 3 belongs to R. And 3, tell me another number. I can take 5, 7, anything. So 3, 5 also belongs to R. From this, am I allowed to conclude that the extreme numbers, what are they?
1, 5.
5 also belongs to R. Right? It makes sense. So like that, you take any combination so that the ending point in the first order pair is the starting number in the second order. So I took 1, 3. Similarly, what is the other example you can take? 1, 5, 5, 9, or 5, 13. Whatever it is, it will still be, you will be able to find the extreme numbers, 1, 13. Are you able to understand? Yes, it is transcendental. Right. Now listen to this. I want you all to concentrate. I would have not got this answer of equivalence relation if I made a change in the question. When do you think it will be? Sorry? Okay, modulus also I think it is useful. But still it is divisible. No, I would have got. So if you take modulus, for instance, what is it you will do? You will take 1, 3. Okay, 1, 1 minus 3 minus 2. Modulus of minus 2 divided by 2 is. It still works. It's divisible, no, as long as you get the remainder to be 0. Okay. So I'm just giving a benefit of doubt. So that point is wrong. Okay, it doesn't work. What if the question instead of integers had they given you as natural numbers? You think it would have worked? Try and see. Don't just conclude. I don't just I told you it's a benefit of doubt. I want you guys to think that it won't. Is he right? Makes sense. Whatever you say makes sense. Too many questions. Are you able to think? Are you able to understand my question? I want you to think because this is where they confuse you. I'll tell you what will happen in examples. They'll give exactly the same question. You know what people miss? They forget to see which set it is coming. I've seen many people doing this. That is why I want you to think. Instead of integer set, had they given you as natural numbers, same question. Do you think this question would have given you the answer as equivalence? I'll give you 2 minutes time. You need not tell instantly, don't do it in the air. You understood this method, right? I'll give you time to copy, leave some space. Use this logic, change integer to natural number set, write it out and tell me. Even if you get wrong answer, I don't mind, try it. But is everyone at least able to understand what I'm asking? Are you able to understand? Okay, try it out. Leave some space for this. Okay? Just look at the board only to take the idea. Don't copy it. Leave some space for it. So what is the change I told you? Instead of integer set, had they given you
Natural
numbers set? Is it still going to be equivalence relation? I'll tell you one more point. Not necessary you need to take A, B, B. If you don't get this, you are allowed to take dummy numbers and check it. You are allowed to do that. But take those numbers which come from this set. Since I told you no natural number set, don't take -1 and take only the number from 1 to infinity. Okay. What did I say? I made a change of integer being a natural number set. Right? I'll tell you how your mind will work. I changed the set to n. So what did you take? You would have taken the natural numbers in the ordered pair as 1, 1, 2, 2, let be. So you take any such ordered pair for it to be reflexive. Let's say 5, 5. Okay. What is the difference between 5 and 5 minus 5 is 0. Your mind will immediately start thinking that 0 is not a natural number. Nothing of that sort. No. What did they say? Whatever the subtraction you do, you get a number. No. That number should be divisible by 2. That is what they told here. They didn't say that this A minus B should be a natural number. They never stressed on that point. So what you told is right. It is reflexive. Then what about symmetric? Symmetric. Saying I already took only natural numbers here. 1, 3 you are getting -2. Don't be worried about this -2 because here they didn't impose any condition. -2 is divisible by 2? Yes, it is. What about 3 minus 1? 2. 2 is divisible by 2? Yes. So it is right. So in this question, right, whether you have an integer set or a natural number set, it is still going to hold good. Even if it is a whole number set, you would have got the answer right. Are you able to understand? Only if they change it to rational numbers or if they change it to real numbers. Had the question been instead of Z or N, had they told you real numbers, don't get confused, there's a set R. Had they told it is real numbers, then your answer would have been. Why? Because real numbers contain fractions also. I can definitely think of fractions where the need not be divisible by 2. Are you able to understand what I'm saying? Sorry. So in this question, in every question based on relations and functions, you know, I want your mind to get tuned to this fact of asking a question of what is the domain. Okay. If I give you the same set, if I change the values here, answer keeps changing. Are you able to think? Right? Make sense? Yeah. -2. That is what I'm saying. They never told that A minus B should. 2 divides that number. Divides meaning another. What should be the remainder? 0. 0 varada. Answer. So when someone says a number is divisible by other, you concentrate on the remainder, not on the quotient. You are concentrating on the quotient of -1. But my concern is of the remainder. Okay. So this is where you need to be careful. Divide symbols together. As I told you, you can also take numbers. Okay. Not necessary. So for example, this explanation is right. You need not take A1, A2, A2, A3. You can take 1, 3 belongs to R, 3, 5. 3, 5 belongs to R, and 1, 5 also belongs to R. It stands. Here, shall I proceed?
Yes, sir.
So this is a textbook solution. Okay. Say they took random numbers, like they took the symbols, but as of now, I don't want to concentrate on it. Once you master the set, I'll explain this problem with another way also. Okay, as of now, we'll go with numbers.